Hi, this video is the second video in Lecture 5. In this video, I will explain how to calculate the present value of bond. We use a two-step process to calculate the present value of bond. First, we draw the timeline of cash flows in a bond. In the second step, we calculate the aggregate present value of cash flows in a bond. In this video, we will use a 5-year bond as the example. This bond will pay the coupon payment in annual frequency. The coupon rate will be 8%. In the first exercise, we calculate the present value of bond with the discount rate 8%. In the second exercise, we calculate the present value of bond at the discount rate 6%. In the third exercise, we calculate the present value of bond at the discount rate 10%. Now let's draw the timeline of cash flow in this 5-year bond. The bond pays coupon payment in the annual frequency, so we will receive the coupon payment in the next 5 years, and we receive the coupon payment at the end of each year. At the maturity date, we receive the face value of this bond. So we will receive the face value and the coupon payment at the maturity date. Now let's calculate the coupon payment for this bond. The coupon rate is 8%. The face value is $1,000. So the coupon payment is 8% times $1,000. It will be $80. That is to say, we receive $80 at the end of each year in the next 5 years. The face value is $1,000 in this bond. So in the 5th year, that is the maturity date for this bond, we will receive $1,000 at the face value plus the coupon payment $80. It will be $1,080 in the 5th year. Given the discount rate as 8%, now we can calculate the present value for this bond. We have 5 cash flows. Then we calculate the discounted value of these cash flows. In the first year, we receive the cash flow as $80. The discounting factor for the first year will be 1/1 plus interest rate. So it will be $80 over 1.08. In the 5th year, we receive the cash flow as $1,080. The discounting factor for the 5th year will be 1/1 plus interest rate to the power of 5. So the present value of the cash flow 5 years later is $1,080 over 1.08 to the power of 5. Then we aggregate all the cash flows together. We can calculate the present value for this bond is $1,000. Now let's do the alternative exercise for this bond valuation problem. Suppose now we have a lower discount rate. It is 6%. We want to calculate the present value of cash flows with this discount rate 6%. For the cash flow in 1 year, it will be $80. The present value for cash flow in 1 year will be $80 over 1 plus interest rate. That is $80 over 1.06. For the present value of cash flow in the 5th year, it will be $1,080 over 1.06 to the power of 5. If you verify the calculation, the present value for the bond at the discount rate 6% will be $1,084. So now we have the lower discount rate and higher present value of the bond. What if we have a higher discount rate? Suppose the discount rate is 10%. Now we recalculate the present value of cash flows using this new discount rate at 10%. For the cash flow in 1 year, the present value of the cash flow in 1 year is $80 over 1.1, that is 1 plus interest rate. For the present value of cash flow in the 5th year, it will be $1,080 over 1.1 to the power of 5. If you verify the calculation, the present value for this bond is $924. So now, given the higher discount rate, we have lower present value for this bond. If you observe the cash flows of bond carefully, you will find we receive the coupon payment frequently before the maturity date. So it is the cash flows of annuity. In fact, we can split the cash flows of bond into two parts. The first part is the cash flows of annuity. The second part is the face value at the maturity date. So now we can derive the present value formula for bond. The present value of bond will be two parts. In the first part, it is the present value of annuity with the payment as the coupon payment, the discount rate as the yield of the bond, and the period as the number of periods for this coupon payment. The second part will be the discounted value of the face value. So it will be the par value or face value of this bond and discounted by the discounting factor, that is 1 plus interest rate to the power of periods. In the previous example of discount rate at 6%, for the coupon payment, the present value of this annuity will be the payment $80 multiplied by this present value annuity factor. We use the interest rate 6% and the number of periods of 5 to find the present value annuity factor. We can also calculate the second part of the bond. We use the face value of $1,000. Then we calculate the present value of this $1,000 using $1,000 over 1.06 to the power of 5. If you verify the calculation, it is very similar to the result we calculated in previous slides. Here we have this slightly difference because of the rounding calculation. In fact, we have a terminology for the discount rate in a bond. We say it is yield maturity. In previous exercise, we calculate the present value of bond cash flows given the discount rate. Now we want to do the opposite direction of calculation. Given the market price of the bond, we want to back out the discount rate to meet the level of market price. We say it is the required discount rate. And if given the market price of the bond, we can find the required discount rate. We say the required discount rate as the yield maturity. Yield maturity in a bond represents the estimate of ex-ante expected return on the bond. Generally, the market interest rate will determine the yield maturity for a bond. If we have the market price of bond different with the face value of the bond, then likely the yield maturity of this bond will be different with the coupon rate of this bond.